Module 26, Permutations and Combinations, Section 1, Fundamental Counting Principle and Permutations. So what is this FCP or Fundamental Counting Principle? Though the name might sound quite unfamiliar to you or fancy, but it's actually very simple. The formal definition is that let E1, E2, E3 to Ek be the sequence of the events. The first event can occur in M1 ways. After E1 occurred, E2 can occur in M2 ways, and so on. The total number of ways that all the k events can occur is M1 multiplied by M2 multiplied by M3 all the way up to Mk. So basically the number of ways events can happen, you just have to multiply to get the total number of possible events. So that is called FCP or Fundamental Counting Principle. Let us say a simple example. A person has got 3 shirts and 4 trousers. So how many ways can she or he wear those combinations? So basically the first the number of ways the first thing can happen multiplied by, after that happen, you have to see number of ways the second event can happen. So the first event is that picking one shirt out of 2. So there are 2 ways that picking of the shirt can happen, and after a shirt has been picked, how many ways the second event, that is picking a trouser, can happen? 4 ways. So there is 2 shirt and 4 trousers. So just multiply these 2. That is what FCP is saying. So if you multiply 2 multiplied by 4 is 8. So there are total 8 ways that this can happen. By the way, this kind of events are known as independent event because there is no ramification of the first event on the second event. So if I say I pick a shirt and after this event has happened, I pick the trousers. So if I did not specifically say about this after this event happened, no problem, it's still same thing. So it is basically these 2 events are independent. It doesn't actually change the probability in the next event as well. So that is called the independent groups or independent events. So you can illustrate a tree like fashion, though there is something called the sample space. So as you can see from the root, the 2 branches coming, those are basically the 2 shirts, and each shirt you can wear with 4 trousers. So 4. So totally if you count that, you will see 8 ways that the person can choose from these combinations. So we have got 4 people who sprints for a competition. How many ways can first and second place finish? So the 4 people. So how many ways the first place can finish? I mean any 4 of them can become the first prize. So the 4 ways the first event can happen. Okay, you already picked one person as the first rank, the winner. Now how many ways the second place, the runner up place, can happen after the first event has occurred? Now we are left with only 3. So it has to be 3. So 4 multiplied by 3 is the total number of ways that this can happen. So you look at this, in this case having the number, these 2 groups are having an effect on picking the first event. So basically these type of events are known as dependent event because the first event can have ramifications on the probability of the next event. So probably in the sense number of ways the second event can happen after the first event happened. So these events are dependent. That is the difference between independent and dependent. Dependent ways events. So another example, let us see 10 people sprints. How many ways can first, second, and third place finish? So the first place can finish in 10 different ways, second by 9, you guessed it, and third, yes, it is 8. So 10 multiplied by 9 multiplied by 8, that is the number of ways you can have it. Few other examples, there are 6 forward primers and 8 reverse primers to choose from for the amplification of a gene. How many different types of reactions can be performed? So you can do that. These 2 are picking the forward primer, does it have any ramifications on the reverse primer? No. So you can simply multiply these two to make the all all over the ways, the final total number of ways. So there are 8 female and 7 male geographical isolates of a dioecious plant. How many ways these plants can be tested for reproductive compatibility? So you have to pick one from 1 out of 8 and 1 out of 7. So 8 ways the first event can happen, 7 ways the second event can happen, and these two are independent. So just multiply these two values together. So you have 4 pants, 4 shirts and 4 jackets. How many ways can you choose 1 pant, 1 shirt and 1 jacket? Again, it's just multiplication of all these values together. In how many ways can you choose triplet codon from a pool of 4 nucleotide? So now that we have 4 nucleotide, how many ways can you choose a triplet codon? So triplet codon means out of 4 you need 3 positions in triplet codon, right? So position number 1 can have 4 ways, second position can also have 4 ways because of 4 nucleotides available, and third position also can have 4. So it's basically 4 to the power 3 is the answer to this question. So everything we did this entire work by looking this fundamental counting principle. We didn't even introduce the term permutation and combinations yet. Then what is this permutation and combination? So you might think about let us say my fruit salad is a combination of apple, grapes and bananas. So if you say this way, you don't care about the order. Do you care? No. Which one do you put first? Banana or orange or apple or grapes? No, that is the order is immaterial. Altogether the combination is basically an orderless. So if the order doesn't matter, it's basically a combination. So the combination to the safe was 472. Well, in this case, does the order matter? Had it been 274, I reverse it, will it work? It will not work. So this so-called combination safe are all order dependent. So in that case, it is something called permutation. So permutation order matters, but combination order doesn't matter. So in that sense, in one sense that this if the order does matter, it's permutation, and permutation is basically the ordered combination. So permutation safe is actually a misnomer. Why? Because it's combination safe is a misnomer. Why? It is not really a combination, but what is going on there is permutation, because the order matters there. So combination lock should be really permutation lock, you see. So now to decide permutation or combination, it's very simple. All you have to do is that do the order matter or not. Let us consider a few examples. The first one is that in a class of 10 students, how many ways can a club of 4 students be arranged? A club means all over 4 students. I don't care about the order at which this happens, so it's a combination problem. So 11 students put their names on a slip of paper and inside a box. So 3 names are going to be taken out. How many ways that you can take 3 names out to be chosen? Again, the order doesn't matter, so the problem is a combination problem. So you are going for a long walk with a music player. You can listen only 10 songs. So but you have to you have a collection of 100 songs. So how many ways can you pick this 10 songs out of 100 songs? Now here the point is that all you need is just 10 songs randomly ordered. Then it's a combination problem, but if the order matters as in the the playlist, then it is a permutation problem. So usually it is it's basically a permutation, I would say. So a special type of password consists of 4 different letters of the alphabet, where each letter is used only once. How many different possible passwords are there? So wherever the password is it is the permutation for sure, because for password the order matter. So it has to be permutation. Or codon also, codon codes for amino acids where the order matter. So if you put in a wrong order, you are going to have a wrong amino acid. So it usually have all the definitions of the permutation in it. So it is usually permutation problem. What is the formula for the permutation? So a permutation is the arrangement of all or part of a set of objects with regard to the order of an arrangement. So that is the formal definition of permutation. So permutation is used where the order matter, the formula is NPR is equal to n factorial divided by n minus r factorial. So this is the formula used if the repetitions are not allowed. There are two formulas. So if the repetitions are allowed, then you have to use n power r. If the repetitions are not allowed, you have to use n factorial divided by n minus r factorial. So I already explained to you what this factorial means. For example, if it is 3 factorial, it is 3 multiplied by 2 multiplied by 1, that is 3 factorial. 5 factorial means 5 multiplied by 4 multiplied all the way to the 1, so that is 5 factorial. So that is what the factorial means here. The one example is that ways to elect president, vice president and secretary out of 20 candidates. So n is total is 20. So does the order matter here? Yes, it matters, So it is a permutation problem. So of course the repetitions are not allowed, same person cannot be president, vice president and secretary. So repetitions are not allowed, just plug this one into the formula of the permutations without any repetitions, that is n factorial divided by n minus r factorial. So here r is 3 because you are picking 3 persons out of 20, n is 20. So 20 factorial divided by 20 minus 3 factorial. So that is basically 17 factorial. So with the factorial problems, it's always better to express both denominator and numerator in the similar factorial to strike them off. So for example, in this problem we have in the denominator 17 factorial, while in numerator we have 20 factorial. So 20 factorial I can also write as 17 factorial multiplied by 18 multiplied by 19 and multiplied by 20. So that is what a simple solution. So that 17 factorial and bottom 17 factorial will be crossed out. So the answer to this problem will become 18 multiplied by 19 multiplied by 20. So that is what you are going to get. The answer is 6840. Next example is that you are going for a long walk with a music player. You can listen only 10 songs, but you have a collection of 100 songs. How many ways can you choose these 10 different songs? So it is basically a permutation problem and without any repetitions. So nobody wants to listen the same song again and again. Well, it's a personal preference though. So usually that is the case. So without repetition, so the permutation problem is n factorial divided by n minus r factorial. So number of the triplet codons possible out of 4 nucleotide bases. So here it is n is 4 and because it is triplet codon. So you are picking 3 at a time. So r is 3. So the order matter, yes, order matter I have already explained. If the order is incorrect, then you are going to get a different amino acid. Well, mostly because of the degeneracy of the amino acid, degeneracy of the codons. So it's a permutation problem for sure. And repetitions are allowed? Yes. In this case, repetitions are allowed. For example, AAG is coding for an amino acid, while AGG might code for another amino acid. So basically, the order matters and repetitions are allowed. So it is basically NPR is equal to n to the power r. So that is 4 to the power 3 is 64 is the answer for this question. Another example, how many anagrams of the word CAT with no repetitions of the letters? So it's basically permutation problem because it is the word, to read it left to right, it is the order matters it. If you change it, then you are going to get a different word. So it's basically permutations of all letters in the word. So how many combinations of the 3 letters can you make it? So that way you can actually see that, so you can easily solve this question by the first principle, the FCP principle. So the 3 letter word, so how many ways, right? It is basically anagram of the CAT. Anagram means the same letter, you have to use it. So the first position of this 3 letter word, there are 3 ways you can choose. Why only 3 ways? Why not 26 ways? Because it's anagram, and because it's CAT, that is only 3. So the 3 ways, the first thing can happen. Second is only 2 way, while the third one is only 1 way. So just multiply all of this to get 6 is the answer. So there are 6 ways you can have it. Example 4. How many anagrams of the word, that is I have already covered this anagram. Example 5. 11-digit phone number in Bathinda starts with 0164. How many different phone numbers are possible? So, to calculate that one, 0164 is fixed. So, whatever is fixed you do not have to care, whatever varying you have to care. So, after 0164, other digits, just let us put the squares of all these digits. So, the first digit, well, 0164 is already there. So, all these are fixed. So, only one way it can happen. So, 1 multiplied by 1 multiplied by 1 multiplied by 1, it is already the prefix. So, do not worry about it. So, the rest, how many ways the first position here can happen? So, basically there are 10 ways, because there are actually 10 different numbers, you see, 0 to 9. So, 10 ways the first thing can happen, first position can happen, then 10 ways the second one can happen, 10 ways the third one can happen, yes. So, how many different phone numbers are possible? Just multiply everything with 10, right. Now, the second question is how many even phone numbers are possible? So, in that case everything is exactly same except the last position, because it is even, only 5 ways it is possible. So, you will have to multiply with the 5 as the last position of these numbers. And how many numbers that end in 193 can possible? Well, why it is 193? Basically 193 is my own landline number, my own extension in Central University of Punjab is 193. So, how is it possible 193 ending? So, in this case the first position 10 ways, second position is also 10 ways, everything is same except the last 3 digits. So, the last 3 digit has to be, it is fixed 193. So, it is only one way. It is possible in the case. So, then you can multiply to see that how many possible, how many total ways it is possible. So, it is all problems of the FCP, you can use it. 6th example here is that how many different 4-length radio station call letters can be arranged if the first position should be W or K, that is fixed. You see ham radio stations have this 4-letter codes, right. So, this is already fixed W or K. Now, second position and third position should be letters that may be repeated, So, both second and third position there are 26 ways that can happen, while the first position is only 2 ways, W or K. While fourth position is numeric. Numeric means 10 different possibilities are there for the fourth position. So, you can just multiply using the FCP principle to solve this problem. 7th example here is how many 5-digit even numbers greater than 20,000 can be formed if digits may be repeated. So, in this case you are looking at even numbers. So, even numbers means the last position of this this string of letters will be only 5 ways, while the rest will be all 10 ways. So, but the first position there are only 8 ways, because it is more than 20,000, you see. So, more than 20,000 means that 2, 3, 4, 5, 6, 7, 8, 9, only that much is possible. So, only 8 ways is possible. 0 cannot be, because if I put 0 in the first, then it is not more than 20,000. Why not 1? Because if I put 1, whatever the number I am going to write is always less than 20,000. So, that is why 2 till 9 is possible. So, there are 8 ways the first event can happen, then 10, 10, 10, 10, then the final one is even, and because of that it is only 5 ways that can happen. So, there are more examples. For example, in how many ways 6 paintings be displayed in a row on the wall of the museum. So, it is a permutation problem, you can solve it that way. So, how many arrangement can be made for using 3 letters of the word dolphin if no letter be repeated? Again, that is a permutation problem, you can solve it very easily. There are 6 polymorphic sites in a gene, each having 2 SNP variants, SNP, which is nothing but single nucleotide polymorphism or the mutations. How many total genotypes are possible? So, in this case you can use either the fundamental counting principle FCP, or you can use permutations with repetition, that is n to the power r. It's very simple problem. How many 20 mer primers are possible? 20 mer means 20 nucleotides. So, how many are these are possible? So, you can use that with the permutations with repetitions allowed, because repetitions are fine with this primer, or the DNA sequence of course. So, n to the power r you can try it out. So, in summary, According to the fundamental counting principle, the total number of outcomes can be computed by multiplying the events together. All you have to do is just to multiply the events together. The ways that events can happen, just multiply to get the overall, the total ways the events can happen. Independent events are the events having no impact on the another. So, for example, gender of two consecutive children. For example, if the first child is a baby girl, so that baby girl have got no impact on the second child. It could be boy or a girl. So, it's the same thing. So, these are known as independent events. So, there is no ramification on the probability of the second event. While dependent events are the events having impact on the another event. For example, drawing a second card without replacing the first card from a deck of cards. So, if you draw a card, then that card is over. So, the overall number of the cards in the deck, it will be one less than the total. So, it will have impact on the overall probability of the remaining cards. So, this is something called dependent events. So, a permutation is an arrangement of all or part of a set of objects with regard to the order of the arrangement. So, that is called permutation, and permutation can be calculated by NPR is equal to n factorial divided by n minus r factorial for repetitions are disallowed, or you can also use the formula n to the power r if the repetitions are allowed. Thank you for watching.